Hi everyone. So just to briefly introduce myself, I'm Abeera and I'm here on behalf of PSI. So we're a body of statisticians within the pharmaceutical industry. So we thought we would give a workshop on some of the work we get involved in and how we apply maths to a real life topic such as medicine. So you all would have had a worksheet with different activities. So we call this activity the nice picnics. And the idea of those worksheets was to learn about the process of choosing medicines for the NHS and how we use some of that mathematics to like quality of life graphs and help back our decisions. So the activity you guys would have had 3 medicines. So thinking about this in a real life perspective, in the UK, we have NICE and the MHRA, and we have a set pool of money to fund certain medicines. So we may have many amazing drugs out there, but we can only actually fund specific ones. So this activity gets you thinking a little bit about that. So you would have Bite Back, Tasty Med, and also Katie, remind me what the third medicine was?
Breathaline.
Breathaline, that's it, thank you. Yes. So yeah, there we are. So just to give you a little bit of a background who the MHRA and NICE are. So the MHRA stands for Medical and Healthcare Products Regulatory Agency. So this authority are the people who ensure medicines work. And there's NICE, which stands for the National Institute of Health and Care Excellence. And these are the authority of people who decide if the UK are willing to pay for the drug. So with each medicine, you would have seen that none of them are completely risk-free. And before new treatments given on the NHS, many trials need to be carried out to assess the benefit and risk of that medicine. So right now, there's a lot of news around COVID, the vaccine, which is currently having undergone trials that would have gone through this process. So there's a lot of different factors we need to take into consideration when we decide whether to fund a medicine. So things like how many people it will help. If you have 2 medicines available, one which can treat 1,000 patients and one which can only treat 100, you may lean towards funding the medicine that can treat more patients. Things like whether it's better than the current treatment on market. If you've got a medicine which is treating, say, a common cold, but you've got a lot of other medicines on the market compared to a novel medicine which is fighting breast cancer or some cancer which doesn't have a treatment, you may lean towards the novel treatment, even though it may help fewer patients. Things like quality of life, which we'll talk about in the next slide. Benefit versus harm. A lot of medicines can have side effects. The probability of the drug actually working, and also how much the drug costs, the cost to the NHS, and whether there'll be some economic savings there. So all of these factors will play a role in helping decide whether a drug should become available. So talking a little bit about quality of life. So why do we measure it? Things like and how it's used. So it helps us have a common comparison. So let me go to the next slide and show this here. So we may have 2 treatments. So the red line is showing a new treatment and the blue line is showing a standard treatment. So what we can do is we can calculate the area there, and that can help us have a measure to assess whether the quality of life is improving. And the way we'd calculate the area, so we'd do base times height for the rectangle, we'd do base times height times a half for the triangle. We can add that together. So then we can say the total change from standard is 1.75 quality adjusted life years. So moving on to the three medicines which you would have had. So Katie, would you like to take over?
Yep, I can do that. I'll just start my video. So, hi everyone, I'm Katie Thorne. I'm another statistician working with Abeera on PSI. So these were the three medicines we asked you to look at, and we gave you a table to fill in order to help compare against them. And this is exactly answering those factors that Abeera just talked through. So there's many factors coming into consideration. The first column is looking at the cost. The second is how many people would benefit. So that's looking at how many people have the disease. That's known as the prevalence. But then if you multiply that by what's the probability of the drug working in everybody, that might not be 100%. It might not be 100% effective. So if you multiply those two things together, you get the actual number of people that benefit. And then, as Abeera just walked through, another way to compare between indications or different types of disease is looking at what's the benefit to somebody's quality of life day in, day out. So we were looking at that over the 4-year range. And so you could calculate the area under each line and then take the difference to do that. And that's the third column. So hopefully you got answers similar to these when you were doing this problem. Your teachers have got the answers as well. But just to pick out an example, say the bottom row of Bite Back, that was a drug for malaria. There was a cost associated with a medical appointment of £30, and then you had to take a tablet that cost £7 for 14 days. So that's how it got to the total cost. Although that looks wrong. Oh no. And then the number of people that would benefit, there's 99.5% chance that would be effective. And then there's 1,600 people with the benefit. So you can get the total number of people that would actually benefit. And the quality of life years, the difference there was a half-year adjusted quality of life. So somebody was gaining on average about 6 months of full health benefit for taking Bite Back compared to a standard treatment. So hopefully you got numbers similar to those. And what we wanted to hear is if you've had a go at completing this activity, if you could put in the chat which drug you thought was most effective, or the one that you would like to fund if you were in the position of NICE and you wanted to pick one. So that would be good.
Recap that, Katie said, what are the options that we can choose from?
Breathaline, Tasty Med, or Bite Back.
All right, which one would you guys want to fund and why, I suppose? Let's just try and get a couple in the chat box if we can. Who wants to be the first one? And then if you're playing along on the recording, again, of course, you can pause the recording to give your class a little bit more time if you need, but it'd be good to know what your class thinks. See if we get any back. Sometimes, Katie, it's been a challenge to get them back in time because the students are still discussing it. So we'll see how we go.
That's okay. We can carry on because I know we haven't got lots of time. So if we go to the next slide, one thing that you may have noticed when going through is that there are pros and cons to each of these medicines. And that's why this is such a difficult decision. So for example, again, with Bite Back, it's cheap. There was a very high probability of response that we just saw. So the 99.5% of people that would work, and there were very few side effects. But it was only a small number of people that actually had the condition. And it isn't a disease that we have in the UK. Although it's serious, it's normally contracted abroad and brought back. So is that best use of our money? And likewise for Breathaline and Tasty Med, there were pros and cons. So asthma is very common. We have lots of treatments already available. Does this new treatment, it is better, but do we need it if there's already reasonably good treatments on the market? So you could argue yes, you could argue no. And the last one, Tasty Med, this is brilliant that it can cure a disease. It's the first treatment of its type, but most cases of tongue and mouth cancer are actually preventable because they're due to smoking. So would the money be better spent on advertising campaigns to stop smoking, for example? So it was a bit of a cheeky exercise. There's no real right answer. But what we wanted just to show you is a taster of how multi-factor problems like this can actually use maths to assess and compare different treatments. So using quality of life, which sounds quite subjective, by using mathematics and statistics, it can really help you compare in a quantitative way to make a decision. So I think we're on to the last slide of this a little bit now. So yes, yeah. So just to say, we've given you a very short taster of one way that maths and statistics is used to compare treatments when we're making a decision. Lots of factors need to be considered when a drug gets approved into the NHS. And quality of life adjustages is just one piece of that puzzle. And in this situation, there were no wrong answers. But it's interesting, if you get, when we've run this face-to-face with people, you get a lot of discussion in the room about the best treatment. So it can be quite a subjective thing. So we hope, if you haven't had a chance to do so, we hope you have a chance to do the activity, and feel free, you can always contact PSI through our Facebook page as well to let us know how you found it as well, or on our website.
Well, I think Line was the preferred, which we got through in the end.
Okay, yeah. I mean, it's often very popular because students are really aware of asthma as well, and many people have it, so often resonates. So yeah, nice. Okay. Should we move on to the career side of things?
That'd be great.
Okay. All right, I will share my screen now. And hopefully you can see the slides.
Yep, we can see that.
Perfect. Okay, so we wanted to give you a short talk about the career path of a medical statistician. So what that involves, how did Abeera and myself get into it, and why we think it's a good option for you to consider in the future. But first, I want to generally talk about what is statistics. So Wikipedia tells us that statistics is the discipline that concerns itself with the collection, organization, analysis, interpretation, and presentation of data. It's a really broad subject, is what I want you to realize. It's vast and incredibly interesting and diverse to work in. And the reason I've got a picture of a toolbox is, I hope you realize, probably your generation even more so than mine, that we're living in a very data-driven world. You can't escape statistics and data. And statistics is that tool that helps us understand big data sets and therefore understand the world we live in. And to give you some examples of that and why I think statistics is so important, I'm going to show you that statistics really is everywhere before we get into the medical statistics side. So when you go to choose your next series to binge on, you get recommendations. How do they get there? It's the algorithm producing the recommendations is based on statistics and probability theory in order to choose the best programs for you. We've just gone through the general election in America, that while the results were coming in, we got predictions on which way each state was going to vote. Those predictions are based on statistical theory as well. So another great example. And one other area that you often see statistics being misinterpreted is actually in the media. That's why I want to encourage you all to at least recognize that statistics is a really good skill for everybody to have, because if we don't, and we're reading about articles with results and data in them and we interpret them in the wrong way, we can be susceptible to be misled, as written here, that poor numerical literacy could be linked to greater susceptibility to COVID fake news. It's just one example of this, but it happens all the time. So how do I use statistics in my job? So again, thinking about the pharmaceutical industry, where our aim is to make new, safe and effective medicines for patients, every time we ask a question about a new medicine, we run an experiment or a clinical trial. That generates thousands of points of data. It's huge. And there's a whole host of people at the other end that need to use that data, whether it's scientists deciding whether to do a new experiment, and regulators deciding whether to approve a drug, or yourselves understanding the side effects of a medicine you're asked to take or prescribed by your doctor. All of those things, to get from data to data consumer, you need a statistician in the middle. We're there to interpret, reliably analyze, and effectively communicate the results and what the data is telling us in a clear and objective way. And so this is where I see myself. I'm the middle ground between data and people who need to understand and make decisions from it. It's an incredibly important role in medical research. So to talk you through some of the things we do on a day-to-day basis. So Abeera and I will work in study teams. So I work on a project for pain and a project for psoriasis at the moment. And you're part of a team. You're representing the statistics group. You're there to be the one statistician on the team, working with scientists, medics, project managers, data managers, a whole host of people. And really our key responsibilities are around the design of the trial. So how big does it need to be? What measurements do we want to take and when? And then the analysis of the trial. What's the best way to analyze the data we're working with? So it's a really nice role in that we're there at the beginning of an experiment, planning it, and seeing it all the way through to the end of the study, where we then analyze all the data and present that back to the team so they can understand the key results from the data we've collected. Actually, one point I wanted to highlight is that lots of areas in the business I work in are really keen to improve their understanding of statistics. So I've actually been doing a lot of teaching. So although I don't work in a school or a university, people want to learn from the skill set that we've got as statisticians. So a big chunk of my day-to-day work is actually helping others understand statistics. Okay, so we're going to talk about why we chose to become statisticians. I've been working in the industry for about 5 years now, and I started off by doing a degree in mathematics. And within about 2 weeks of being in my degree, I realised I didn't want to work in finance. And that cuts down a lot of your options as a maths graduate. So you can't be an accountant, you don't want to work as an investment banker. There's many finance jobs, but for me, they just didn't seem to be interesting. I was very fortunate that when I was looking for a placement in between my second and third year, where you go and work for a year in an industry, I stumbled across a medical statistics job in a neuroscience team. And it seemed like the perfect blend of the subjects I'd enjoyed at school, like psychology, maths, and chemistry. And really, after spending a year there, I never looked back. There were so many interesting problems and challenges in the real world that were just so exciting to me that I've never looked to go any other way. But what I'd like to now is hand over to Abeera. She can talk you through her experience as well and the rest of the presentation.
So for me, the reason I became a statistician, so back when I was doing my A-levels in college, I was very torn between doing medicine and a science-based subjects and maths. In the end, I decided to go with maths because that was the subject I enjoyed the most, but I still wasn't sure exactly what career I would go into. And I think it was around my second year where I did an internship at an Institute for Preventative Medicine. And that was the first time I actually got to see some of the work medical statisticians do and how they sort of collaborate with wider team members. I really enjoyed my time there, and it motivated me to pursue a master's in medical statistics. I then went to attend this PSI careers fair, which we hold annually, and I found Amgen, which is now the company I work for. And overall, it's been a really interesting time. You get involved in a lot of different projects. There's clinical trials, but there's also observational research, which looks at how medicines are in the real world compared to clinical trial settings. Next slide. Yeah. So just to talk a little bit about the routes into the role. So for me and Katie as well, I believe we had very similar routes getting into the industry. So we both did A-levels in mathematics, and then we went on to do our degree in maths. So that can either be university or it can include an optional placement year. Following that, almost all people pursue a master's in statistics, specializing in medical statistics. And from there, you can get a graduate job as a medical statistician. So we talked through, so that tends to be the most common route getting into industry, but it's not to say it's the only route of getting into industry. So there are people who've done other degrees besides mathematics, say biology or psychology, but they have elements of statistics in there, which allows them to then pursue a master's in medical statistics. Some people may even opt to do a PhD before they get a job in industry. There's also qualifications while working. So some people might do a master's part-time while they're in industry, or there's also apprenticeship schemes which are being looked at. So they may be available in future as well. So talking through some of the skills we use as a statistician, one of the big ones is teamwork. We work in a wider group. So typically it'll be a medical person, the statistician, and either a safety person or an epidemiologist. And the reason for that is everyone will have their own expertise. So we'll be the data specialists, but someone else can provide a little bit more insight into some of the medical meaning of that. Communication is really important. A lot of people think if you're in a data role, you're pretty much typing away at the computer, doing lots of numbers, but actually you need to be able to communicate what you find in layman's terms to people who don't understand statistics as well. Logical thinking. One thing I find we tend to bring a different perspective to the team because we're thinking about it from an analytical perspective. So it's quite good having a different school of thought coming in, so you get a wider perspective. And flexible. So everyone has different timelines and deadlines. People tend to be quite flexible in the way they work, but equally the companies we work for tend to be flexible in allowing us to move around our time. So what makes medical research exciting? So these are some perspectives. So one of them is methods and technologies are always advancing. I'm constantly learning and developing my skills. I can see a full career ahead of me, not just a job. Working with real patient data, knowing that I'm analysing some real survival time reinforces the responsibility that I have. Having the opportunity to help develop treatments for rare or serious diseases with no current treatment, for example, COVID. And I love working in a role which combines lots of subjects. I enjoy maths, science, and psychology. So in conclusion, the main purpose of this is it's to show maths and statistics enables you to work in any field. We work particularly in the medical side of it, but there's so many different areas which need statisticians working. Particularly for medical statistics, we use our statistical skills to help transform the lives for the better. And ultimately, it's more than just a job, it's a career, and it's a very rewarding one at that.
Fantastic, thanks Abeera. Have we got time for some questions now? Is that the end of the presentation?
Yep, that's the end. I can stop sharing.
No, that's fantastic. What an interesting presentation and enlightening. I just wonder, in terms of apprenticeship opportunities, guys, like GSK have apprenticeships, don't they? Katie, is that right?
We do, and it's something that, in terms of the role that Abeera and I do, it's being worked on because we need to set a standard bar, if you like, across industry. So it's not company specific. So for medical statistics, I believe it's still in progress. And PSI that we work with that unites companies, all statisticians across companies, is working on that. I believe at GSK specifically, there are ones within the data science organisation already set up, but it's only something we'll see more of in the future.
Okay, understood. And for students looking to become statisticians, so it is all about maths, right? We've got to keep doing maths, obviously GCSE, then keep going at A-level and onwards, is that right?
We would love to encourage you all to keep studying maths. It does keep your options really wide open. You know, we're not saying everybody has to go into medical statistics. Obviously, it is the best choice, but it's we did want you to be aware that it's statistics in itself is used in every industry now because everybody relies on data and data interpretation, which is exactly what you're training to do. So the beauty of it is that you can study a subject and then pick the field that interests you, whether that be environment, whether it be medical, whether it be finance or sports statistics. It's really broad. But obviously medical is the best.
It's the best one, of course. And I just wonder, with your stats brain on here and your knowledge, what do you make of the COVID-19 vaccine that we're hearing about? What sort of comes up in your mind when you look at that and what you question around it potentially?
Well, I will disclose that I will speak fully on my own personal views here, not the company's, not PSI's or Abeera's. I'll let her speak as well. But I think it's incredibly remarkable that the hard work that people have put in to develop vaccines in such a short space of time, and to tick off all the regulatory hurdles that they need to do to ensure it's safe, are all being done. And I think I'm personally very excited. I was reading about the expected levels of response rate, which have been seen to be 90. People were not expecting it to be that high, FDA and others. So the fact that we've got 90% already with this first vaccine is really promising and exciting.
Fantastic. Abeera, what would you add to that in the topical?
Yeah, I think, again, I'll reiterate it's my own thoughts here, but I agree. I think when you start to work on the pharmaceutical side, you see how many checks and hurdles have to be crossed before a vaccine can actually make it to market. So I think the timeline they've got the vaccine made in is incredible. So yeah, I think it'll be quite exciting to see how it progresses.
So
the full results will be interesting. Yeah, I was just going to say, obviously this is only the interim, so seeing the full results will be obviously incredibly important and from a safety side point. But it's promising.
It's interesting. So without people like you, we'd be struggling to get that sort of stuff through the door to people like that.
Yeah, and actually that was a point I should have made, is that timing of the interim and the analysis that was shown and the timing of it is up to a statistician to choose how much data do we need in order to make some form of early reasonable decision. And that comes from statistics. So it's such a good example. The fact that everyone's talking about it is brilliant.
That's so good, guys. When you go home to your mum or your dad or your mum and dad tonight, make sure that you let them know that, you understand more about the COVID-19 vaccine and spoken to the experts. If there are any questions, do let me know. But I was really intrigued by the Netflix algorithm. So there'll be people working away to make sure that the things I'm clicking on continue in that sort of rhythm. And that's all down to stats, is it?
Yep, exactly. So you hear a lot about machine learning, and really the more the models, it's all prediction models. That's all it is, and that's something that you would study if you did a maths a maths degree with statistics components. It all feeds into it, and they use the data that you've submitted through your previous choices to then pick out the ones that are most like those and make predictions back to you. So it's a little bit scary how your data is used, and this is why it's such a hot topic about confidentiality and use of accepting cookies and things like that. It all plays into these things. So good to be aware, but can have really positive benefits.
Definitely. And we've only got time for one more question. I think I'm going to ask it to Abeera and then Katie just to follow up with. What would you say to students who are in year 9, kind of like maths, kind of good at it, but sitting on the fence about whether to go down that route or not? They have to do it next year in GCSE, but in terms of A-levels and university and beyond, bit of a pep talk from you, Abeera, and then over to Katie.
Yeah, so I would definitely, if you're even considering, well, maybe I should do maths, maybe I shouldn't, I always say it's always a really good subject to take. It keeps your options open. So I think I mentioned in the slides, for me, I was set on medicine, and I even had my UCAT exam and booked, and about 2 days beforehand I went to an open evening and I sat through the maths lecture because my parents were running late to pick me up. And I just thought, you know what, I find this so interesting and I really want to do maths. I don't know what careers are out there, but I'm just going to go for it because this is the subject that interests me. So I never had it in my head that I'm going to be a medical statistician in future, but it fell into place.
That's amazing. Katie, final words?
Yeah, I think that's a great answer. But just to echo, if you're on the fence, please just consider it. It does keep your options really broad for the future. I certainly didn't even know this job existed. Even at university in my first year, I didn't know about medical statistics, but I just knew that maths was an interesting subject, and I thought I'd just keep going for as long as I could. But it's really brilliant that you've got careers events like this to tell people about the interesting jobs at the other end. So I hope people do feel motivated to keep going.
There we go. And that's a great note to end on. We do know about it now. So thank you so much to Katie. Thanks so much to Abeera. An excellent lesson today. And thanks, students, for joining. Thank you.
Thank you.
Thank you.